Gang, Mr. Sprague, back at it again with the homeroom math. Welcome back, my homeroom friends. This is Mr. Sprague coming to you from the OHS math department up in F215, bringing you the second installment of homeroom math. Now, I apologize for not having it to you in the past couple weeks. I've had a bit of a crazy schedule, a lot of things going on around homeroom time, so that hasn't worked out, but things are back to normal now, we hope, so things should be mathematically proficient from here on out. Today we're talking about factoring. Factoring is a really important concept. We're going to see this idea pretty much from about the first half of Algebra 2 all the way to the end of it. So it's really important that we have an idea of what factoring is. Now, factoring can take on two different forms. We can actually pull an item out of each term, like what's going to happen in here, or we can take what we call a trinomial or a binomial, like these are trinomial and binomials, and separate them into two smaller parentheses. And just by looking at these or practicing these a bunch, we should be able to see eventually which one it is right away. So I'm looking at this and I'm noticing that both terms have something that can be divided out. And that number is 16. So what I'm going to do is I'm going to factor a 16 out of it. Now, one word of advice though, if this number is ever negative, if the leading number is ever negative and you're trying to factor it, it's always a good idea to factor a negative number out. We don't want this leading number to be negative. So I'm going to actually factor a negative 16 out. Additionally, what I notice is that these both have t's in them. This is t squared, this is t, this is 2 t's, this is 1, which means that I can actually factor out a number of t's out of it that can divide out of both terms. Well, in that case, it's just a single t. After I factor that out, I've got some stuff remaining here. And let's take a quick look. I had negative 16t squared. I divided it by negative 16t. Well, it seems to me like that just leaves me with a plain old t. Next, we have negative 48t, and we're dividing that by negative 16t. Well, that's a positive 3. There is my complete factorization. We're going to do the exact same thing here, but with just some different numbers. Looks like 5 can factor out of both of these terms, and x can factor out of both of these terms. Now notice this first number is not negative, so I'm not going to factor a negative 5 out. I want to leave this positive if I can. So I'm going to factor out a 5 and an x out of both terms, leaving me with x, because 5x squared divided by 5x leaves me with just x. Additionally, 10x divided by 5x is 2, and this is negative 2 here. So my final answer looks like that. Number 3 is not quite like that. What I'm looking for, I guess it is kind of the same. What I'm looking for is something that's common to all parts of the expression. Well, looking at these two expressions, I notice that they both have x minus 1s in them. This is called factoring by grouping, so I'm actually going to factor out an x minus 1 from both terms. Additionally, what I now have, if I take x minus 1 away from this term, all I have left is 3. All I have left after x minus 1 goes away is x. That is my finished factorization. I can't go any further than that. For number 4, this is going to be a two-part problem. I'm looking at these and I'm saying, okay, a number can divide out of both of these. It's 52. Additionally, I'm going to be able to factor this a little bit further. We're going to get into that in a little bit. I notice that these both don't have x's in them, so I can't do the idea that I did for numbers 1 and 2. So I'm looking at this and saying, I think 13 can divide out of these. 52 divided by 13 is 4. I didn't divide x out, so this remains as x squared. This 13 got divided by 13, so it's now 1. Now, that looks all fine and good, but we can actually go one step further because this expression can factor this one expression can now break into two smaller expressions. This is what we call a difference of squares because 4x squared is the same thing as 2x times 2x. 1 is the same thing as 1 times 1. Again, a difference of two square numbers. So I've got the 13 from before. This now factors as 2x plus 1 and 2x minus 1. I can't do anything more to that. That's my complete factorization. For question number 5, in your Algebra 2 class, I hope that you saw something like this. We're trying in the Oñate Math Department to write this or use an X box method, or the X factor method, you might have heard it like that. And that looks like this. We have a giant X. In this X, this is going to be our number that we're trying to multiply to. So we want to try to multiply to 4. On top of that, we want to add to 5. Which numbers will now multiply to 4, but at the same time we'll add to 5? Well, it's going to be 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. So my factorization for this is x plus 1 and x plus 4. If you have these inverted as x plus 4 and x plus 1, that's perfectly okay. Lastly, we have number 6. Number 6 is going to look a little bit like number 3. We're going to do one more step beyond it, but we've got this. Both terms have an x in them, so I'm going to factor that x out of it, leaving me with this is 2x plus 5 after I take this x away. 2x plus 5 plus this x went away. All I have left then is x minus 10. And that looks good, but we can actually go a little bit further because I'm looking to combine like terms. I'm not multiplying these two, I'm adding them. So I'm looking to any like terms that would be together, 2x and x. That's going to leave me with 3x. So there's the x from before. So I have 3x. Lastly, I have 5 and I have negative 10. A total of negative 5. That is it, my friends. We are completely done with this problem. Good luck to you.